Okay, a little quadratic equations review. We're going to study quadratic functions, so we probably better review our methods for solving quadratics, all right? So let's take a look. Do you remember doing any of these? Can I solve by factoring, taking square roots, completing the square, quadratic formula? Those are our four methods, all right? So factoring is really important. Right, so a quick review for factoring. I like to break it down like this. I'm going to always look for the greatest common factor. If I can factor that out, I'm going to do it. After that, I look for two things. Difference of squares, something like a squared minus b squared, and those factor linear sum, and then its conjugate. What else do I look for? I look for these guys. X squared plus bx plus c. They'll factor like this. And then I need to find two numbers that multiply together to give you c, add together to give you b. Alright, so those are the two numbers we're looking for, and I can just plug them in there. And then my other case, that's when I just have a 1 for the x squared. I make these two different cases. Ax squared plus bx plus c. This is the toughest case, I think, when this number is not 1 or it's greater than 1. And then I'm going to do what's called the AC method. Okay, and we'll see each of these come up in my examples. All right, so in this review, I'm not reviewing factoring, I'm reviewing solving by factoring. So just one more additional step in the factoring, we still have to solve. Okay, and I'll talk about that when we get to that step. We'll use what's called the zero product principle. Okay, the first thing I need to do whenever I'm solving a quadratic equation is set it equal to 0 most of the time. So I'm going to add 5x, I'm going to add 6 to both sides. And I'm going to factor. I'm going to say, okay, what can I do from my factoring methods? There's no common factor. I don't have to worry about that. And it looks like one of these guys. One of these guys goes like this. Right, and I know when I do if I were to FOIL, because we're doing the opposite of FOILing here when we factor this one, it's x times x to give me x squared. And then let's see if we can find the two numbers. So in this case, it's two numbers that multiply together to give me 6, add together to give me 5. 6 and 1 aren't going to work, it's close, but it should be 3 and 2. Okay, that's the factoring piece. Now the solve by factoring looks like this. A real quick review of my zero product principle goes like this. If I have a times b equals 0, think about that for a second. Two expressions multiplied together equals 0. Then what has to be true? Well, a could be 0, right? Because 0 times anything is 0. Or b could be 0, right? Because 0 times anything a is could be 0. All right, now it looks like a pretty standard or basic or straightforward formula concept, but we're going to use it here. That means this guy could be 0 to have a solution. And we'll do this all the time when we're solving by factoring. This will be like my last step. I'll do the factoring first, then I'll apply this concept. And I set each factor to 0 and solve. Subtract 2. In this case, I would subtract 3 and I get 2 solutions. All right, you can always do the check. Does that work? Let's just check one of them for time's sake. Plug it into the original equation. I think -2 is an answer, so does it work? I'll put a question mark there. Is that the same thing? -2 squared is 4. And -5 times -2 is 10. 10 minus 6 is 4. I'm pretty happy that's an answer. Okay? All right, let's look at some other examples here. So 4x squared minus 25x, I go to my list, and I look for the greatest common factor. In this case, I got one. There's an x in both of those. So I factor out the x. Whoop. Almost made a mistake. Oh, I didn't make a mistake. Factor out an x. I get 4x, because x times 4x would be 4x squared. And there's my greatest common factor. And then what's left? Well, I can't do anything else because I don't have a quadratic anymore, right? It's got two linear functions. When I get down, or two linear statements multiplied together, when I get to that step, I just set each part of the linear, or set each part of the product, I should say, this times this equal to 0. And use that zero product principle. So there's one answer. If I solve this, I'm going to add 25 and divide by 4, and I'll be done. 4x equals 25. And I get my second solution, 25/4. Okay, I want to do, oh good. I was just going to do this one. So I want to show you the difference. Look how similar example 2 is. 4x squared minus 25x equals 0 to example 3. But they're different problems. In this one, there's no common factor. So my list, I always look for that common factor. And then either I factor it out and move on, or if there is none, I move on to my difference of squares, which I think I used a squared minus b squared, which is what this one is. All right, this is a perfect square, and this is a perfect square. So what do I do to factor that? Well, here's how these ones work. You take the square root of the first guy, square root of the second guy, and then one gets a minus, one gets a plus. Why does that work? Well, you can always check your factoring by multiplying out. So this is the reason it works. The f in FOIL is 4x squared. So this will be my check of my factoring. You can always check your factoring. The O in FOIL is this. That's a 10x. The I in FOIL, and this is the whole reason it works, because this will always happen. And then the L in FOIL is minus 25. And the reason there's no x term for these is because it would cancel out if you did the multiplication of what you got when you factored. It's always going to happen. 10x minus 10x is 0. And then you get your original equation. And that is why it works. Difference of squares. Okay? So that's the factorization piece. Now the solution piece, and I'll skip a step here. Set each of these to 0, and you should get these two answers. 5 halves, one's positive, one's negative. All right. Now for my more complicated type, it's my AC method. All right, so let's walk through this one. So I'm going to set it to 0 like we did in the other cases, which is always what we do when I'm solving quadratic equations by factoring. Always set it to 0. We do completing the square later. We won't necessarily set to 0, but when I'm factoring, I'm always going to set to 0. Okay? Now, there's no GCF. Can't do that. It's not the difference of squares. Can't do that. It does not look like this guy, where it's like the easier case. It looks similar to that guy, but notice the difference. When I factored this one, there's a 1x squared, or just x squared by itself. So this is my category, well, 3 or 4, or C or D, A, B, C, D, category D or category 4, where I have a number that's here that's not 1, or in other words, not x by itself. So I got to do the AC method. So let me show you that. AC method goes like this. My standard quadratic is ax squared plus bx plus c. So that means that's a, that's b, and that's c. So step 1, multiply a times c. In this case, that's 12 times negative 2. That's negative 24. Step 2, find two numbers that multiply together to give you negative 24, but we'll add together to give you the middle number of 5. All right? What are those two numbers? Well, what multiplies together to give me negative 24? 24 and 1, 12 and 2, those aren't going to work. 8 and 3, I think I'm on to something. 8 and 3, one of them's going to have to be negative, and I need a positive 5, so I'm going to make my 3 negative. 8 times negative 3 is negative 24, check. 8 plus negative 3 is 5, check. The whole reason we're doing this for the AC method is the goal is to break up that middle number, okay, using these two numbers that we found. So I started with 12x squared. I started with a minus 2. I started with an equal to 0. And I started with a 5x, but we're going to rewrite the 5x using these two numbers. So I'm going to replace 5 with what it's equal to. And 5 is equal to 8x minus 3x. 5x is equal to 8x minus 3x, right? That was 5. And this will allow me to do some factoring. So I do a little dotted line. It's my next step. Now I do factor by grouping, factor out my GCF of these two terms. That's going to be a 4x. I can take 4x into both of those. What does that leave you with? 3x plus 2. There's nothing to factor out of here, but the goal is I want the same expression there. So if I factor out a -1, I get a 3x plus 2. All right, this is a long method, the AC method. And then what do I have? Look, I got the same thing here and here. So what I'm going to do is I'm going to factor that guy out. So this is going to look a little weird, but this is common. If I consider that like one term and that a second term, this I can factor out. That's a common factor to the front, the 3x plus 2. And what does that leave you with? Just what's on the outside here, 4x minus 1. All right, that's the AC method. And the last step would be set both of those to 0. I'll skip a little work there and get my two answers.